right, now we have a picture of how it's going to look like. We got to do some calculations, okay? How do we do the calculations? Very straightforward. We have to see the time for each aircraft from the point of departure to the point of the turn. This one's going to turn right, this one's going to turn left. So let's go and start with aircraft A. Aircraft A is going to travel 1,500 nautical miles at 419 knots. How long it's going to take? It's very simple, okay? 1,500 divided by 419 equals 3 hours and 34 minutes and 47 seconds. If that airplane departs at 0830 and it travels from departure till the turn, 3 hours, let's round 34, 47. Let's round it up to 3 hours and 35 minutes.
All right.
It's going to be 0830 plus 0335 equals 1205. It's going to be 1205 UTC when it turns right.
Yes.
Okay, very good. Now let's look at this aircraft. This aircraft departs at 8 and it goes 1,600 nautical miles at a speed of 520. 1,600 nautical miles divided by 520 equals 3 hours and 4 minutes and 36 seconds, which we're going to round up again to 3 hours and 5 minutes. Mm-hmm. It's going to depart at 0800 plus 3 hours and 5 minutes equals, you tell me?
11:05.
11:05, okay? It's going to hit 11:05 and it's going to turn. This one's going to turn at 12:05. This guy goes faster and less distance and speed, and it gets there faster because it left faster, okay? So it actually
Aircraft
gets
B
there.
is faster.
Aircraft B is faster, and it gets to that other side of planet Earth an hour earlier. Okay? Now, the next step is to find out where aircraft B will be when aircraft A is at 12:05, which is going to be traveling this way another hour. Mm-hmm. Okay? To find that, we have to find how many nautical miles it's going to travel on the great circle of 7420 latitude. To do that, we take cosinus of 7420 equals 0.2700400328 times 60 degrees. Times 60, which is the nautical miles per degree. Turns out to be 16, 20, 24, and so forth. So we'll put that number here at aircraft B. 16.20241973. Now, we have to take the speed of the aircraft and divide it by that number. And that equals 520 divided by this number. That equals 32 degrees, 5 degrees, 38.3. So that's going to be just about here somewhere at
12:05.
12:05. And we'll mark that here. 32 degrees, 5 degrees, 38.3. That's how fast it's going to travel in an hour on this latitude. Mm-hmm. Okay? Now, we have to do the same thing with... now we have to find out where it's going to be here. So we'll have the latitude, the longitude 160 minus this will give us the point here. And we'll mark it. So, minus 160 minus 32, 5, 38.3 equals 127, 54, 21.7. That's where that airplane is going to be. That's west on at 12:05. So far, we know where exactly both airplanes will be at 12:05, which is going to be the next calculation.